Welcome back. This is the second lesson recording for IM1, March 9th, 2021. Card number 6. Okay, now the question is asking, what is the starting value from this function here? Starting value, if you recall from your equation, is the when x is equal to 0 or the y-intercept. So what is the y-intercept in this case? It's 6,000. So the starting value is 6,000. And then from here, every time the x is increasing by 1, it's being multiplied by some number. Okay, from this equation, what is the starting value? In this case, what do we know about the starting value? 0.4 is the multiplier because that's the number with the x as the exponent. The number without the exponent is the starting value, okay, and that is going to be 3. Okay, now we're going to go on to card number 8 and 11, 8 to 11. This time we are going to talk about salary gain. CUHSD teacher salary is modeled by the equation. Let's say this is the equation that models the salary. X is the number of years they've been a teacher, and Y is the salary in year X. Okay, so in year X, this is the representation of the salary. That means in year 0, or when X is equal to 0, what is the starting value? Okay, starting value when a teacher does not have any experience in teaching, when he has a 0-year experience, the starting value is 60,000. So what is the salary of a new teacher? That's going to be 60,000. Okay. All right, and then from here the multiplier is 1.05. Remember, the 1 comes from the fact that we need to multiply the original, and 0.05 or 0.05 is the percentage increase. So we are multiplying by 105%. The 100% comes from the fact that we are adding the original amount. So each year it is increasing by 5%. 0.05 is same as 5%. So it's increasing by 5%. Then you submit. Okay, and then the yearly tuition at University of California, Berkeley has been increasing since 2010. In 2010, the tuition was $12,000. Every year increased by 200. Let X be the year since 2010. Let Y be the tuition for X year X. Which of the following equation best models the tuition? Okay, think about this. That means in year 0, okay, the tuition was 12,000. Or when year 0 really is talking about 2010. Okay, so then year 2011, that will be considered year 1. And increasing by 200, that's going to be 12,200. And then year 2, it's going to be 12,000, and then you're increasing by another 200, so that's going to be 400. Okay, so that's how it's increasing. How would you describe this equation? Is this exponential function? No, it's not. You are adding the same amount each year. So this is what? This is a linear function because you're adding 200 each year. So it's going to be 200x plus, what are we starting with? It's $12,000. This is y equals mx plus b. M is the unit rate, and b is the y-intercept or the starting value. Okay, so it's coming back all over again, isn't it? So this is y is equal to 200x. 200 is how much you are increasing every single time, every single year, and then you're multiplying that by number of years, and to that you're adding the initial value. Okay, what about tuition at Stanford. Okay, Stanford's tuition was $39,000 in 2010. Okay, in comparison to 12,000 at UC Berkeley. Every year it increased by 3%. This time we have a percentage increase. Then what are we going to be multiplying each of the previous term? Okay, no, so we have 3%. So 3% is 0.03. Are we just going to multiply 39,000 by 0.03? If you do that, that's just going to give us the increase, how much it has increased by. But instead, we are going to add 1 to it. So 100% plus 3%, that is going to be 1.03. So we are going to multiply it to 39,000. Okay, so then that means 39,000 is the initial value, and this is the multiplier. So what is the equation? The initial value is 39,000 multiplied by not 3%, but I want 1.03 because I want 103%. So it's going to be the first option in my case. Okay, and then you get to chill a little bit waiting for other students to catch up with you. You need to look for the B. There is a B somewhere. It took me a long time to find it, but there is a B somewhere. See if you can find it yourself. Let's quickly summarize what you should have noticed from your Desmos activity. Remember, we compared the UC Berkeley tuition and Stanford tuition. We said that in year 0, UC Berkeley's tuition was $12,000. Stanford in year 0 or 2010, it was $39,000. Okay, Stanford is a private university, California. UC Berkeley is not. Okay, so that is the price difference. Do not quote me on these numbers. Okay, it's just approximation at best. So, and what are we told? We're told that UC Berkeley increased each year by $200. Okay, this is all hypothetical. If that is the case, then in year 1 we have, and we are going to consider all the different years. In year 1 we are going to add $200. In year 2 we're going to, whatever the previous amount was, which was 12,000 plus 200, we're going to add another 200. And year 3 we're going to add yet another 200. Notice what you see here, 200 plus 200 plus 200. 200 is being added 3 times. So instead of just keep adding 200 multiple times, we can represent this as 200 times x for the year x. And to that, we have to add the initial value of 12,000. In comparison, what about Stanford? Okay, we're starting with 39,000. But each year we are increasing by 3%. That means we are going to be multiplying by, not by 0.03, but 1.03, because we want to add 100% to the 3%, because we need to add whatever we started off with. Okay, so if I just multiply by 3%, I am just going to get the increased amount. But I also need to add what we started off with as well. So that's why you're going to add 100% to 3%, which is 103%. So you're therefore multiplying by 1.03. So 1.03 multiplied by 39,000, that's the first year. And then second year, whatever the previous value was, you're multiplying by 1.03 again. And then you keep doing that, adding one multiplication of 1.03. So for year X, you can generalize this as, well, multiplying 39,000, and then we're multiplying that by 1.03 multiplied to itself x number of times, or raised to the power of x. Great, so now you're going to change gear a little bit. We're going to be reviewing multiplying polynomials. Okay, we did this in the first semester. Okay, if you recall, if you're multiplying an expression, we call this binomial by another binomial because we have two terms. What we did was, well, we always want to simplify what's inside the parentheses. But 2x plus 5, can you simplify what's inside anymore? No, you cannot, okay? And 3x minus 4, they're not like terms, so you cannot do that either. When you have two numbers in parentheses, say if you have this 3 and 5 in the parentheses, what is the notation, mathematical notation? This is really same as 3 multiplied by 5, right? That means this is still same as this 2x plus 5 is being multiplied by 3x minus 4. So to do that, we have done the area model, and we have said, okay, so that is same as, this is my width, and this is my length. So width is 2x plus 5, and the length is 3x minus 4. And then from here, we multiplied each of them. So we are multiplying. So 2x times 3x. 2x times 3x is 6x squared. And then 5 times 3x. 5 times 3 is 15. 15x. Okay, so then what about this square? 2x times negative 4. 2 times negative 4 is negative 8 times x. And 5 times negative 4 is negative 20. Okay, so we have problems like this. Okay, then from here, what did we do? We needed to combine the like terms, didn't we? So what are the like terms? We add the x terms. So this is currently same as, this is same as 6x squared plus 15x. We add all the terms plus negative 8x minus 20. But when you combine the like terms, this is the two green part, it's these two, or 15x minus 8. What happens? You still 15 minus 8 is 7x. So you have 6x squared, everything else stays the same, plus 7x minus 20. And so that's my final answer. Okay, I am going to show you yet something else. Okay, so all right, so what you are actually doing is, look what you're doing here. To figure out the answer, what you did was you multiplied 3x by 2x plus 5, and that's 6x squared plus 15x. So I am going to use, this is going to be called full distribution. And this is actually what you've been doing. You've been doing distribution method. So 3x is being multiplied to 2x plus 5. Okay, and then to that, that's going to give you the 6x squared plus 15x. To that, you're adding, this time negative 4 is being multiplied to 2x plus 5. Negative 4 is being multiplied to 2x plus 5. That's what you've been doing in the area model. And then from here, you're using the two separate distribution. So 3x, so now from here, I am going to say, I'm going to multiply 3x to 2x. 3 times 2 is 6. X times x is x squared. 3x times positive 5 is 3 times 5 is 15. Multiplied by x is going to be 15x. Now, then you're going to add negative 4 times 2x. Negative 4 times 2 is negative 8. And then multiply by x. And negative 4 times positive 5 is going to be negative 20. Then from here, you're combining the like terms. The like terms are these two. So you get 6x squared, 15 minus 8x, which is 7x minus 20. You get the same answer as before. Okay, so you can do it more algebraically, or using the full distribution, or the area model is really just